Welcome, math adventurers. Today, we are diving into the world where letters meet numbers and logic meets creativity and math becomes magical. That's right, we are talking about algebra. Don't worry, algebra isn't just jumble of x's and y's. It's actually a powerful language that helps us to solve problems, spot patterns, and even predict the future. Now, let's break it down. 1. Algebraic expressions are like ingredients of recipes, a mix of variables, numbers, and operations. Think of something like 3x plus 5. You can't solve it, right? But it's saying something. It's expressing a relationship. Like for every step you take, you earn 3 points plus 5. Not bad, right? 2. Equation. Equations are like when we say, okay, now let's solve a puzzle. An equation tells us that two things are equal. Like 3x plus 5 is equal to 20. Now we can ask, what value of x makes this true? And boom, you're officially a problem solver. And finally, we level up to functions. Functions are like machines. You put in a number, which is input, and they give you a result, which is output. If f of x is 2x plus 1, and you feed in 3, the machine gives you 7. It is maths magic, predictable, powerful, and it's everywhere around us. So whether you're solving mysteries with equations or building machines with functions, algebra is your toolkit for thinking smarter, solving better, and exploring deeper. We can now say that there are 3 forms of algebra, which include 1. Algebraic expression, 2. Algebraic equation, and 3. Algebraic function. Linear expression of the form ax plus b, e.g. 3x plus 5. Quadratic expression of the form ax squared plus bx plus c, e.g. 3x squared plus 4x plus 5. Polynomial expression of the form ax cubed plus bx squared plus cx plus d, e.g. 3x cubed plus 4x squared plus 5x plus 6. Exponential expression of the form a raised to power x plus n plus b a raised to power x plus c, e.g. you can have 6 raised to power 2x plus 1 plus 7 6 raised to power x plus 5. Logarithmic expression of the form log a raised to power x plus b, e.g. we can have log 3 raised to power x plus 5, whereby the base is 10 or any other basis. And the last, trigonometry expression of the form arc sine x plus b, e.g. you can have arc sine of half plus 5. And all these also go for algebraic equation, whereby all the types of expression becomes equal to 0, 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 and all this becomes equations. In theory, a function of any graph is expressed as y is equal to f of x. So for algebraic function, all these are the types of algebraic function, whereby f of x are added to this form of functions. So this becomes f of x is equal to this, 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 and f of x is equal to sine x plus 5. So all these are functions as y is equal to f of x. So we can easily say that this is y, as y is equal to 3x plus 5. Algebraic function expressed the graphs of equations because of its dependent y variable and independent x variable. One is the linear graph. It can be in this form or in this form, whereby it passes through the origin, and here it passes through the y-axis. So it's an intercept at the y-axis. Y is that intercept here is 0. So this is y is equal to mx. And here, y is equal to mx plus c, whereby this c is the intercept and m is the gradient. 2 is quadratic graph. Quadratic graph is parabolic in nature. It can be drawn like this or like this, whereby this indicates that this is parabolic at maximum point and this is parabolic at minimum point. So we can have that this is y is equal to ax squared plus bx plus c, and this can be expressed as y is equal to ax squared minus bx minus c. 3 is polynomial graph. Polynomial graph is always cubical in nature or presentation because y is always equal to x cubed. So it can be drawn like this. You can have it like this or like this. You can move like this. So this is y-axis and this is x-axis. So we can have it in this form or this form. 4 is the exponential graph. Exponential graph always travel from the negative infinity to infinity along the x-axis like this. So we have it like this. It can travel like that. So this is y is equal to a raised to power x as it travels from here to here. So this is negative infinity to positive infinity along the x-axis. 5 is logarithmic graph. Logarithmic graph is like the inverse of exponential graph. It travels from the negative infinity along the y-axis to the positive infinity. So it can be drawn as thus, like this, as the y-axis and the x-axis. So this is the y-axis and this the y-axis, and this is the x-axis. So it travels from the negative infinity along the y-axis to the positive infinity. So it moves in this form. So y is equal to log x. This is the graph. And for the last graph, we have trigonometric graph. This graph has different shades, ranges from the sine graph, cosine graph, or the tangent graph. For sine graph, we have something like this. It can be like this, whereby this is y-axis and this is the x-axis. So this is the graph of y is equal to sine x. I know you have learned one or two things from this video. Click on the notification button to get notification of other videos. And don't forget to follow and subscribe. See you in my next video. Bye.